Hi everyone, I will reshare the Kahoot link. Please join. Others, please join. We'll start by 9:05, or if you people join as soon as possible, we'll start it. Please join fast.
Hi, hi everyone. Good morning.
Good morning, people.
Yes, good morning everyone. All right, so we'll be starting with the data visualization in Python in today's session. So what we'll do is we will quickly create a new notebook, new folder as data visualization in Python, and this will be a pure hands-on part, hands-on coding part. So less theoretical, more practical in today's session, right? So in that data visualization in Python, we'll create a new notebook and we'll start to work on this. Just a minute, just a minute. Yeah. So uh, let us quickly put heading as introduction to matplotlib, and we'll see what is data visualization. So data visualization is an important skill to possess for anyone trying to extract and communicate insights from the data. To get great business narratives and presentation often stem from brilliant visualization that can convey key ideas in a concise and aesthetic manner. In this field of machine learning, visualization plays a key role throughout the entire process of analysis to obtain relations or relationships and observe trends and portray the final results as well. So therefore, it is imperative that you learn and master this tool, which will aid you throughout this particular program. Now, in this session, this session will help you out to learn how to visualize data in Python using matplotlib. So we have two libraries basically. We have matplotlib and we have cbon that are widely used for data visualization. And cbon is built over matplotlib. So it supports matplotlib. It cannot be used independently. Cbon. You have to use this alongside uh your matplotlib, right? So data visualization is a key uh key step. Data visualization is a crucial step in the process of data analysis, right? Let us understand that. Now, in this session, we are going to see how do we create. We are going to see creating and plotting graphs. We'll see different chart types and we'll see modifications of chart for better understanding and presentation, right? We'll see this. So why there is a need of data visualization, we'll try to understand that with very, very beautiful example. Why there is a need of data visualization. Very beautiful example. So in order to explain this, I'll just share my Excel screen. Just give me a minute. I'm just All right. So consider there is one retail store uh, in different locations of India. And from that, taking that particular example, we'll try to understand why there is a need of data visualization, right? So we have month over here. We have month over here. Month can be, as you know, it can be Jan, Feb, and so on. So I'll just take out this November and December. Okay. Let's say we have till November. Here we have a location, Mumbai, and here we have discount. Here we have sales. So I'll select this uh, and I'll merge and center this. Right? Here we have Bengaluru. Here we have Hyderabad, and here uh, Bengaluru is this, Hyderabad is this, and Kolkata is this. Right? So we have discount, we have sales. Here also we have discount, we have sales. And here also we have discount, and here we have sales. Okay, so let us try to add some values. Can you can you just confirm? Is it not visible, guys? My screen? Okay, okay. Just a minute. I'll just share entire screen. Can you see it now, everyone?
Yes, Vipul, we can see.
Right, perfect. So let us take this highlight. Let's do some cosmetic work and let us create a table. So this should be one table. All borders, we can have all. This should be one table, and starting from this, it should be another. So basically, we have multiple tables. Alright, and let's create for this. Okay, perfect. So now let us try to add some values, right? Let's say 10, 8, any random values, 13, 9, 11, 14, 6, 4, 12, 7, 5. Here we have 568, 482, 1084, 426, 724, 996, 833, 881, 758, 695, 804. Discount. We have 10, 8, 13, 9, 11, 14, 6, 4, 12, 7, 5. Here we have 914, 814, 874, 877, 926, 810, 613, 310, 913, 726, and 474. Here we have Hyderabad. So discount is okay. Discount, I think it's same for all the cities out there. So we can copy and we can paste it over here. 10 at 13, 9, 11, 14, 6, 12, 7. And here, let's say we have 8 for all. 8 for all except August. Except August. We have 8, 8, 8, 8. August we have, let's say, 19. Here we have 8, 8, and 8. And let us try to add sales. Over here, let's add 7, 4, 6, 6, and 7, 1, 2, 7, 4, 711, 781, 884, 608, 539, 815, 642, 574, 689, 791, 556, 1250, 525, 704, 847, 884, 771, 576, 658. Right? We have this data now. Now see, what we'll do is we'll try to find mean. We'll try to find mean of all the quantities. So let us look at some summary values. Let us look at the some summary value. So what we'll do is we'll calculate the average and we'll calculate the standard deviation. So for this, we want to calculate average. We'll write down is equals to average of all this records. It is 9.27. Similarly, here is equals to average of all these records. Why there is 9.27? Just a minute. September it is 12, I think. Then it will become 9. Yeah. Here also average of all these records 9 equals to average of all these records becomes 9. Right? And if you just see average of sales as well, if you just see, it will also be 749 for all the somewhere around 750. Just a minute. How we can change this is 724, let's say. Right? Here also, if you just drag this down, 750, 750, 751, this, right? Hmm. So, what do you think now? As this summary value tells us the same story out there, if you calculate standard deviation for this one, it is coming out to be 3.16. And if you calculate for all the records out there, 193, 3.16, 193, 3.16, 193, 3.16. So it is same, right? It is same. So this summary value tells us that this all stores having the same uh, behavior across different locations, right? This summary value tells us, gives us an idea that all are same. Yes or no? The performance of all the stores are same. Is it same? Can I say that? By using summary value, I can say that. So as you can see, the average discount rates and sales and their corresponding standard deviation across each of the branches are exactly same. Does this imply that all the branches have the same performance? What is your guess? Does this imply all the branches have same performance?
Yes, Vipul, can say.
The answer is no. I'll just show you. What you'll do is you'll plot a scatter plot for these two records. I'll select this. I'll add insert. This is your scatter plot. This is your scatter plot for Mumbai, right? for which city? Mumbai. Let us do it for. That's why there is a need of data visualization, right? Your summary statistics tells us the it is same. But if you quickly just plot the uh, what we can say scatter plot, or if you visualize your data, then you'll get a clear understanding of the pattern of this particular store or performance of this particular store, right? So your summary statistics will fail out over there. What is second? This is your Hyderabad, right? Let us add third. Insert plot. Oh, it's here. This one. This is for which city? Bengaluru.
Actually, previous is Bangalore.
No,
Vipul.
no. Okay. That's fine. That's fine. Not a problem. I can change only
Okay.
here. Suppose this is Bengaluru and this is Hyderabad. And there's one last thing that we need to add for this insert. This is Kolkata. So that is what we have for this data visualization, right? Now, if you compare this thing, you'll understand that all the store has different performance, right? The pattern in underlying data and the difference become apparent when visualized through appropriate plots. So each of the branches had actually employed a different strategy to calculate discount rate, and the sales number were also quite different across all of them. It is difficult to draw this type of insight and understand the difference between each of the branches using raw numbers alone, this raw numbers alone. So therefore, you should utilize an appropriate visualization technique to look at the data. And in the next segment, let's focus on few examples of data visualization, right? So this example that I've given, discount and rates example that you saw above, is actually a modified version of a popular dataset called Anscombe's quartet. If you want to read about that, you can go and read this on Wikipedia. Anscombe's quartet. So, see, it's a modified version of a popular dataset, Anscombe's quartet, right? You can read this to get an idea about what is that particular point, right? Now, uh, the statistician Francis Anscombe constructed this example to counter the notion of numerical calculations are exact, but graphs are rough, right? That's why this particular example he has uh, taken out. Now, second example that we can take is by a popular website. Uh, I think it's Gartner, for the particular survey of different cricket players and their strike rates across all their format. So Gramner is the website, and if you just see ODI India batting visualization by this Gramner, this is a very beautiful example to understand why data visualization is needed. Now, if you see, this is for popular cricket playing nation, since we took every batsman that has scored at least 20 runs in their ODI career, plotted their run rate across every single match. Size equals to number of runs. So higher is the size, higher is the number of runs. Lower is the size, lower is the number of runs. Color is equals to strike rate. So if it is red, it means player is playing very slow. If it is green, means player is playing considerably, significantly good amount, good with the good strike rate, right? So as you can see, as everybody knows, Sachin has highest score. This is little earlier because if you see Virat Kohli, he only has 7,000 run. So it might be the chance that it has taken very 5 or 10 years back. But let us consider this. Now, if you just try to see this, you'll get an overall understanding of everything when it comes to run, when it comes to strike rate, and when it comes to a particular name, right? But suppose if you have one data in which you have player name, right? Their runs, their strike rate, and their matches. Would you be able to get this much understanding easily? The answer is no, right? By just having a look at the data, we don't get an idea what is the maximum, who is the maximum, who has scored maximum run, who has scored maximum run with the maximum strike rate, like that, right? So if you see comparatively, people often considered as Rahul Dravid plays slow in ODIs, but that is not the case, right? He plays faster than, let's say, Yuvraj Singh at the strike rate, or he plays faster than many of the players. If you compare this with Machari Srikanth, he was known as a fast striker of the match, but he has scored relatively less strike with relatively less strike rate as compared to Dravid, right? And highest strike rate is for Yusuf Pathan, but his run is very less. That's why there might be chance that he has scored with the highest strike rate. Sachin Tendulkar is having highest run with the good amount of strike rate, 87.1. Virat Kohli plays fast. Rohit Sharma also plays fast. Then Gautam Gambhir plays relatively slower than uh, Mahendra Singh Dhoni and Yuvraj Singh scored. Likewise, you can compare. Sunil Gavaskar is slow. So that's why there is a need of data visualization. And if you just double click on this, or if you just not double click on this, for each and every inning out there, there will be a beautiful explanation for that particular inning. So if I just hover my mouse, 200 runs at the strike rate of 137 on which particular date? 24th Feb 2010. Where? In the stadium versus South Africa. And this is another inning, 21 runs, relatively slow. He played at 58.3 uh, on 17th October 2007 versus Australia at 1 kid. So everything is given with very detailed fashion. You can see that. Is it fine? So for each player out there, what is his highest score in ODI? You can get an idea about that. For Yuvraj Singh, what is highest score? 139. Rohit Sharma, probably 264. Everybody knows that. Virendra Sehwag, 219. Rahul Dravid, 153. 183. Kapil Dev is also 175. This is 123. Right? So everything is given over here. Clear explanation. But by just having a look at your data, you'll not be able to see that. Right? Yes or no? And scorecard is also attached to this particular thing. So Gramner is a very uh, excellent, or we can say effective website. Uh, it's a subsidiary of Gartner. They are famous for their visualization tools or their visualization kind of work. So the company is Gartner management consulting company, but they have very beautiful insights and trends for all the uh, uh, statistical comparison for all the things out there. It is famous for their visualization part, right? So you can have a look at this in your free time. I'll just share the link with you. So these are the two prominent reason and more than sufficient. The reason why we require to have an understanding of your uh, data visualization. Why there is a need of data visualization. Is that making sense, everyone? Yes, guys.
Yes, Vipul.
And let us look at the final example why we should learn data visualization. There's one another survey by moneycontrol.com for market movement on budget 2005. Uh, And there is also we have beautiful uh, what we can say visualization by the same company, Gramner, and you'll understand that which particular sector has highest stake for the particular year of budget. So you can just check it out for 2005. It is banking and financial services. They have, and here we have news, right? So that particular news mark that tobacco. Tobacco has shrunk budget from this particular amount to this amount. That is also one of the charts that we have. So we have seen this. This is known as heat map. We have seen this. This is known as scatter plot. And we are actually having a look at the Indian budget history. That is also known as another chart, which we'll see. So every year on the day of budget, the share market shows considerable movement. For example, in 2007, every sector fell from, with the exception of tobacco, and same happened in 2009 as well. But in 2010, every sector except tobacco rose. So similarly, almost every banking stock fell in 2012, with the notable exception of HDFC, whereas 2010, almost every banking stock rose. Tobacco, which is dominated by ITC, has grown on every budget day since 2004, except 2010 and 13. On the other hand, media and entertainment has shrunk in every budget except 2011 and 12. So, in this visualization, you can explore the market's reaction on every budget day from 2004 to 2014, and size of the box represents market cap of the company or sector on the morning of the budget. The color represents growth, and the red color represents shrinkage on the day of the budget. Right? Another beautiful thing you can have a look at. So that's why you get an understanding, right? If you use different plots, different graphs, how our task becomes simple. That's why there is a need of data visualization in machine learning. So this chart is known as tree map. This is known as tree map, and the other one is known as heat map. An important point to remember is that visualization should be accompanied by a voice or text narrative if possible. It improves the experience of the user drastically, right? And now let's see how visualization can help in visual exploratory analytics. We'll see how data visualization help in understanding the connection between software and clustering them together based on common features. So we'll have a discussion on another visual now. So there is another visual by software ecosystem cluster by this Gramener only. If you just see, they have provided in the form of cluster. So this is known as clustering. Explore alternatives to various softwares used on day-to-day basis. This is visual inference interface to alternative veto.net, and you need to search a software, filter by any tag, or adjust the size of the network to explore interesting structures. Here are some interesting searches. Google. If you just search, you'll get an understanding of Google and their product. Translate, Hangouts, Docs, Chrome, right? Picasa, Google Drive, Google Docs, Google Plus, Google Calendar. So you will get each and every product understanding. Then for Microsoft, for music, you have different apps and their cluster. Spotify also there, right? Then what is this Audacity? This is XVC Media Center. iPad, applications in iPad, window games, right? And several things are there, right? So this is known as clustering approach, cluster, which is also very helpful to understand the data in very simple and effective manner. So that's why there is a need of data visualization. So I've given you 4 link. You can go through that for a quick look, and then we'll see. We'll quickly go to the uh, coding part, right? So it's 9:43. Let us have 7 minutes of break. Let's explore that particular link which I have shared, and we'll be back exactly at somewhere around 9:50, right? And we'll start the coding part. This is your coding. We'll start with that. Okay, so let us start with the coding part now. So as we have discussed earlier in SQL as well, there are two types of data, right? One is called as facts, another is called as dimension. Graphics and visuals, when used intelligently and innovatively, can convey a lot more than the raw data alone. Matplotlib serves as a purpose for of providing multiple functions to build graphs from the data stored in your list, arrays, etc. So let us start with the first lecture on Matplotlib. Before we start discussing different types of plots, you need to learn about the elements that help us create charts and plots effectively. So there are two types of data. One is fact, another is dimension. Facts and dimensions are different types of variable that help you interpret data better. As you know, facts are numerical data and dimensions are metadata that explains the numerical data, right? Metadata means it explains the additional information associated with the factual variable. Both facts and dimensions are equally important for generating actionable insights from the given dataset. For example, in a dataset about heights of student in a class, the height of the student will be a fact variable, whereas gender of the student would be a dimension variable. You can use dimensions to slice data for easier analysis. In this case, distribution of height based on gender of a student can be studied, right? And identifying facts and dimensions among variables are effectively will help you out to start your analysis of a given dataset, right? So that's why there's a need of your what we can say facts and dimension. Now, let us have a look at the visualization. I'll do this. I'll share code so you can refer that. So let us work on a case study. Online retailer. As a part of example number 1, we are going to study bar chart, that is plot sales across each product category. What is a bar chart? A bar chart uses bars to show comparison between categories of data. And a bar graph will always have two axes, and one axis will generally have numerical values or measures, and the other axis will describe the types of categories being compared or dimensions, right? So let us import numpy as np. Let us import matplotlib dot pyplot as plt. And let's add product category. Let's create a data np.array. In real world scenario, you don't need to create a data, but for just basic understanding, we'll create a data. So we have array of furniture, technology, and office supplies, and we have sales is equals to np.array of let's say 411045 dot 90 comma 4744557 comma 50 comma 3787492 dot 5. plt dot bar product underscore category, comma, sales, plt dot show. Though this is a simple bar graph. How can you do that? You import matplotlib as plt and you write down plt dot bar. On x-axis, you write down first variable that is for x-axis, second variable that is for y-axis. Simple. So on y-axis you have sales, on x-axis you have product category, right? Now you can modify bar graph. That is also possible. You can color, you can add a color, or you can write on bar chart is equals to plot sales across each product category. First is adding labels to axis. Second is reducing the bar width. Third is giving title to the chart. Fourth is modifying the ticks to show information in $1 million. Right? How do we add labels? So what we'll do is, let us take the same data. You don't need to take a data, you already have that, but I want everything that should be in a single line. So I'm taking this data. I already have this data. So there is no any need of taking this data. If I generally don't take, that is also fine. Or if I just keep this as it is, then that is also fine. Now I'm plotting bar chart and setting bar width to 0.5 and aligning it to center. So plt dot bar product category sales, comma, width is equals to 0.5, comma, align is equals to center align, comma, color age color is equals to orange, comma, color is equals to CR. Right, if you run this, the width is set, alignment is center. Width, if you see, it is less as compared to earlier graph. Width is less. Alignment is center. Age color is orange, right? And color is cyan. You can give any color out there. If you just refer to the official documentation of plt.bar, you'll understand what are the different colors. Just plt.bar. Yeah. If you just go to official documentation of matplotlib, you'll get to see all the parameters are need which we can pass inside this to create a bar graph. And there is no any need of using all the parameters. It totally depends upon user, whatever he wants to do, he can go with that, right? So that is your coloring. Now you want to add and format title. So we'll write on plt.title, which will give you the title of the graph. Title that you want is sales across product categories. This is your title. So this is your title, right? But if you want a space between title and graph, you can write down /n to add a space. See, there's a space between graph and title, right? Now I want to modify this. So I'll create a font dictionary and I'll add font size as 20, comma, font weight as 5, comma, color as green. Done. So green color for title, right? Now, if you want x-axis label, y-axis label, you can do that. Let us do that. Labeling axis, plt.x label. X label is product, category, font, dictionary again will create. You can create the same dictionary. So I can create the same, I can take the same dictionary over there and paste it over here. This. And font, let us change color to, let's say, brown. Font weight should be 5. Size should be less. So as this is title, we have given 20. Let us give for axis label as 12. So product category 12, right? 12 font and color is brown. Similarly, you can add plt.y label that can be your sales, and you can create the same font dictionary which you have over here. So I'll just copy this, I'll paste it over here. This is my Y label, right? This is my Y label. Is it clear? How do you add Y axis label? And one more thing, let's say, as this values are in 40 lakhs, 47 lakhs, 37 lakh. So I want to represent this as 3 million or 4 million or 4 million like this. So how can I do that on the y-axis? There's one little caveat that you need to do. It's not needed, but I'll just show you how to do that. Modifying the text to show information in million dollars. So M should be that M on x-axis on y-axis. So ticks, I'll arrange ticks as np.arrange from 0 to 60 lakh. So 1, 2, 3, 4, 5, 6. And with the difference of 1, means with the steps of 1 lakh arrange, we are arranging that. Everybody knows that. Oh, everybody knows this. And now I want M. I'll just format this with I divide by floor division. 1 lakh, 1, 2, 3, 10 lakh, 1, 2, 3, 4, 5, 6 for I in ticks. And I'll write on plt dot y ticks. X-axis will be ticks, and this will be labels. This will be labels. So y-axis will be labels. I mean, on you can see this is 5 million, 4 million, 3 million, right? So that is what little changes that we have done for this particular thing. So you can quickly have a look at this code. If you have any questions, you can ask. Otherwise, we'll just shift towards the next part. Yes, anybody have any question? What is that M? That is nothing but this, no? This M. Whatever result will be there, this result, you're storing it inside this. And M will be there at the end. Okay. So let us go to next now. Next part. Next is your scatter plot. Let us try to understand how do you plot a scatter plot. So I already have a data created. I'll just copy that. Just instead of creating this data, let us copy this data and let's try to understand what is scatter plot. Just a minute. This is your data. Let us take this. Let us paste it out here. Right. So we have sales, we have profit, we have product category, we have country. Right. Now I'm going to plot scatter plot, scatter chart. So I'll write on plt dot scatter profit comma sales comma alpha is equals to 0.7 and size of the dots that we'll be having on this the scatter plot is 50. This dot you can change size to 100 or 10 depending upon your requirement. What is this alpha? It's another parameter that we have. If you just go to official documentation of matplotlib plt.scatter, you'll understand what is that alpha or what are the different parameters that we can add inside this. So we have alpha. The blending value between 0 to 1. 1 is opaque and 0 is transparent. So if you want some, so it is not transparent. Can you see this? 0 will be transparent. Transparent. 0.5 will be little less transparent. So 0.7. That is your case. Right? And now you want to add title and color, title and access to this. You can do that. Adding a formatting title. Same thing you can take. Suppose I want the same title. I mean, title should be different, but I want the same uh, thing. Font dictionary should be same. So I can take this. Instead of this, I can take everything, X label, Y label, and I can paste it over here. So I can have uh, title as somewhat different. Sales versus profits across various countries and product categories. This should be my title. And everything should be same. X label is profit because on X axis, what you are writing X axis as profit, Y axis as sales, and Y label as sales. Same. If you run this, you'll get this thing, this one, text 0.5. If you don't want that, you'll write a field.show to remove this part, this description about the graph. If I write down this, it will get removed. Is it fine? Now, how do you plot a scatter plot? So it gives an understanding of your relation between the data. If you just read this, why do we plot a scatter plot? So of y versus x with varying marker size or color, it is generally used to plot a relation, to get a relation between the data. How much data is scattered. So this is known as scatter plot, right? Now, scatter plot, you can modify this little uh, I mean, you can do some cosmetic works. Suppose in this scatter plot or scatter chart, you want to plot sales versus profits across various countries and product categories. So you'll represent product category using different colors. And you'll add a legend to product categories. So you'll write on plt.scatter profit of product category is equals to technology, comma, sales of product underscore category is equals to technology, comma, C is equals to green, comma, alpha is equals to 0.7, comma, S is equals to 150, comma, label is equals to technology. That is your one scatter plot, right? Now you want another scatter plot. So you can copy this, you can paste it over here. This time profit product category should be office supplies. Here also it should be office supplies. Here also it should be label, also it should be office supplies, right? You can copy this, you can paste it over here. Third title should be furniture. So you can copy this, you can paste it over here. Here also it should be furniture. And here also it should be furniture. Right? Color, let's change this color as cyan. And let us change some size. Here it is 150, so it should be less. It should not overlap. And here it should be 50. Right. Right. So if I do this, you can see there are different scatter plot for different uh, chart, right? And you can add a title and label the axis, which we have done earlier for the scatter plot. So I can take the same thing and I can paste it over here. So this is what we have. Now, you want to represent, this color represents what? You want to have an idea about that. It should be here, right? That is known as legend. It explains which color represents what characters. So return plt.legend for that. Open and close bracket. So this is your legend. And lastly, you'll do plt.show to get the idea. I mean, to remove the unnecessary value. I mean, this part you don't want. So you'll return plt.show. So that becomes your okay. There are two green color actually. This should be yellow. This should be different color, right? Let me give yellow. So yellow is for office supplies, green is for technology, and cyan is for furniture. Now it is looking good, right? So that is your modification of your scatter plot, right? Next is we'll be having a discussion on line plot. Or line chart, which is nothing but I want to plot sales across 2015. So a line chart will help me out with this, or line plot, or line graph, or curve chart. Is a type of chart which displays information as a series of data points called markers connected by straight line segments, and most commonly used with time data. Used with time data, right? Now I have a data already created, so I won't be creating a data. I'll just directly use that data for our analysis. So this is months and this is sales, right? Now I want to plot line plot. Simple syntax plt.plot. X-axis I want months, this month. Y-axis I want sales. So I'll just paste it. This is a line chart, simple. But there are little problems associated with this x-axis. You cannot see it properly, right? So if it is January like this, I want to rotate this by 90 degree at least to uh, have a look to understand this or to get a better view of that particular x-axis, right? So how do we do that? How do we do that? You'll write on plt.xsticks. Rotation. What should be rotation for xsticks? 90 degrees sufficient for me. I can do that. Oh, just a minute. Not here. It should be here. Right? 90 degrees sufficient. So that is done. Uh, Color you can add for title. So let us take the same thing, this title, and let us paste it over here. So I am just adding and formatting title. This is my title. Now, labeling axis plt.x label. X label is months. Font dictionary is, can take the same dictionary as this two. Right? Uh, X axis label is month and Y axis label is sales. If you do that, the rotation is remaining. We'll do that. This one, this is 550K, right? This one is 550K, 500K. So I want that. So I'll write on ticks. Same thing which we have done earlier. nb dot arrange from 0 to 6 lakh with the steps of 50,000. Right here, step size is 50,000, 450, 500, 550. So step size is 50,000. Labels is equals to k dot format I divided by 1,000 for I in ticks and plt dot y ticks labels, right? And you want rotation, so plt dot x ticks rotation should be 90 degree. 90-degree rotation. And you don't want this. So what you'll do? What you'll do? You'll write on plt dot show. Simple. So your line chart is created, which you can see over here, right? So that is your line chart. Now we can have example 5, that is histogram, and we'll just discuss what is histogram is. So as everybody knows what is histogram, you plot a histogram for sales distribution across countries. I mean, this is your question. Across countries, you want sales distribution. And what is histogram? Histogram is a plot that lets you discover and show the underlying frequency, underlying frequency distribution, that is shape of a set of continuous data, right? So let us take this data for histogram and let us try to work on that. This is my data in profit, right? So now I want to use histogram. I'll write down plt.hist. Histogram of what? Profit column. Profit. Simple. It is created. Now this thing is known as bins. So how many bins do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have 10 bins. Suppose you want beans is equals to 20 or beans is equals to 50. So you can write down that beans is equals to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. Right? I'll just write down 100 just for the sake of simplicity. This is my histogram for the 100 beans. And age color that I want is orange. And color that I want is cyan color. And I'll write down plt dot show. So cyan color, right? Cyan color, and what is that? Age is orange. And for this as well, you can have x-axis, y-axis. That is not a problem. You can have plt dot title as histogram for profit, right? This is little bug. You need to restart and run all this. There is a bug in Jupyter Notebook. That's why you are getting that. So that is your histogram. There's a okay. So that is your histogram for you, right? Now in the same output, you want let's say different graphs. Like in the same output, you want different line graph for different categories, like this. Suppose this is for Europe, right? This is for US, this is for Latin America, and this is for Asia. How can you do that? So that is known as subplots, right? The problem statement is I want a line chart for in the same output for different categories. So I'll just create a data for that, in which I would be having years, sales Africa, sales USCA, sales Latin America, Asia Pacific, and Europe. And before that, let's add example description for this example. That is subplots equals to plot sales for various markets for years 2012 to 2015. Subplots are shown in the same graph as line charts, but which is identified by different colors. So I want same output but different line chart, right? So first of all, you need to create figure and axis. You need to set it as subplots. This is your syntax. You're setting a figure over here. Then you will write down Europe, comma you should give, because it should not treat as a list. I'll just explain why we are giving comma over here, this comma. Let me explain. Let me finish this line and then I'll explain. See, if I don't give comma, it will consider it as a list, right? If I don't give comma, so I'll not be able to set label as euro. I'll not be able to set label because list object it considered as a list. So you're not able to set a label. So if you have to avoid this, you should put a comma over here. Simple. The label is given euro, right? Similarly, you will be having USCA, comma, is equals to x dot plot ES, comma, sales underscore USCA, this one, right? And you can write on USCA dot set underscore label. It should be USCA, label it should be USCA. And line graph, you want to set dashes. So not continuous line, dash should be there. So 2 comma 2 comma 2 comma 2 with the interval of 2 2 2 2 like this. So this is your dash, right? Then third is for Africa is equals to x dot plot. You want to plot years, comma, sales underscore Africa, and you'll write an Africa dot set underscore label, Africa, Africa dot set underscore dashes, dashes should be 2 comma 2 comma 5 comma 2. And there will be Asia exactly equals to this x dot plot years, comma, sales underscore Asia underscore Pacific. And for this Asia, you'll set label as Asia Pacific. And then you are going to set dashes as 2 comma 2 comma 10 comma 2. And there will be Latin America, comma, x dot plot years, comma, sales underscore Latin America, Latin dot set underscore label Latin America, and Latin dot set underscore dashes should be 2 comma 5 comma 5 comma 2. Done. List object. Somewhere, see here I have not used comma, right? Africa. So it is considered as a list. You cannot add a label. You should add a comma over there. This is created. Now it's time to add a label. Sorry, legend. So I'll add on pld.legend. The legend will be created over here. And you want pld.legend out of box to anchor. That is also one argument that you have. 1.31 to 0.4. So it will be here outside. Legend will be there, but it should be, I don't want this to be inside a box. I want outside of the box. So it is outside of the box, right? Now, last thing is plt.show. Done. Simple. So that is your subplots. This is 1, this is 2, 3, 4, 5, 6. Everything is with different colors with different dashes. So this dash format is different. 2, 2 dash with the interval of 5, something like that. This might have, because dashes, if you see, the pattern of dash is different, right? For Latin America, which is violet, the dash pattern is different. This is different. This is different, and this is different, right? So that's why we are adding this. If you ask Gemini, what is that? You'll be able to see that. That is not important. That is just a cosmetic part, right? This method set a dash pattern of a line. Argument 2 to define the pattern of dashes and gaps, right? Draw a line with a segment of length 2 points, keep space of 2 points, repeat this pattern. So these are the different patterns, right? So that it summarizes your data visualization, but we need to do last part that I'll just show you. Two graphs are there, but you can have a look at this. If you have any questions, you can ask. Otherwise, we'll go to the next part. So what I need to do is I am interested in multiple subplots, but this time it should be like this. So I'm interested to define the number of rows, number of columns in this. So number of columns, let's say if I define three, so three column will be there. Number of rows will be two. So at the max, in the same output itself, you can have six different graphs of your choice. Either it can be bar graph, here it can be bar graph, here it can be scatter plot, here it can be box plot, here there is another, let's say, uh, line chart, right? Here there will be bar graph. So in the same output itself, you can have multiple graphs like this. We'll see that, right? So let us try to understand that particular point.
I have a doubt, Vipul.
Yeah, go ahead.
In legend plt.legend b box to anchor, you have written 1.31 comma 0.4.
Mhm.
What is the value, Vipul?
That will be, I think, size on x-axis and y-axis. It's just a parameter. See,
Okay.
the argument specifies the coordinates of the bottom left corner of the legion's bounding box. 1.31 indicates the legion will be placed at 1.31 times the width of the plot to the right of the plot's right edge. And 0.5, the value indicates that the legion will be placed at 0.4 times the height of the plot up to bottom. So that is just a modification. There is no any importance of this. You can skip that. But you just need to have a dimension of that, right? You can skip that. B box to anchor. But there should be a dimension specification. You need to specify that. That's why we are specifying 1.31 and 0.4. It is not like this, like you should add only this particular value, right? You can add 2 or 12 and see the changes. Can you see this? 1.31 will be little good. 1 will be more good, right? Here also 0.2 is below, just below to this. Just see the change between this distance, right? 0.1, the distance here, right? Can you see? It
Yes,
is changed.
Vipul.
So that is what it is.
Yeah, got
For
it.
1.31 and 0.4, it was here. So it was looking good. That's why we have chosen that, right?
Yes, Vipul.
Okay. So it's time to go for subplots and then we'll have a break. So two plots we are going to have, as I discussed. You need to define number of rows, number of columns. You need to define number of rows and columns, and then you can go ahead with the next part. I'll write on figure, comma, axis is equals to plt dot subplots, and columns is equals to 3, and rows is equals to 2, share x is equals to true, share x and share y means we are they are sharing the x-axis and y-axis. It should be common. See, share x, sharing x-axis, three graph sharing x-axis, this three graph sharing common x-axis, this three graph sharing common y-axis, this three graph sharing common y-axis. So that's why we are writing down this. They should share the common y and x-axis. Then Europe. comma. First position, 0, comma 0. Means, see, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Right? So at the 0th position, 0 position, 0, 0 means, yeah, here. 0, 1 means here. 0, 2 means here. 1, 0 means here. 1, 2 means here. Sorry, 1, 1 means here. And 1, 2 means here. So 0th row, 1 row. Right? 0 row, 0th column. 0 row, first column. 0 row, second column. First row, 0th column. First row, first column. First row, second column. So we'll just write down this 0 row, 0 column. I want plot. Which plot? Line plot. Because plot means simply, plot simply means line plot. And you'll set Europe dot set underscore label as Europe. This one. Can you see this? First is line graph. Second. So what you should do? You should write a second graph name USCA, suppose. Which will be equals to AX of 0 here 1. It should be bar graph. So dot bar between years and sales USCA. USCA dot set underscore label. Label is USCA. Third Africa is equals to AX 0 2 dot scatter years comma sales underscore Africa dot set underscore label. Label is Africa. Asia comma AX of 1 comma 0 dot plot. You want to plot years comma sales underscore Asia underscore Pacific. Asia dot set underscore label is Asia Pacific. And Asia underscore set Asia dot set underscore dashes. It will be 2 comma 2 comma 10 comma 2. And Latin America comma equals to AX of 1 comma 1 dot plot years comma sales underscore Latin America. So last two will be line plots. Latin America dot set underscore label. Setting label as LATAM and Latin America set underscore dashes as 2 comma 5 comma 5 comma 2. And we'll write on PLT dot show to get the output. There's something too many values over here. Line number 6 here. Okay, should not be this.
Africa also you miss comma. Okay.
No, see, let us understand why there is a need of comma and why there is not a need of comma. It is known as tuple unpacking. When you use plot function, it returns tuple containing one or more line 2D objects depending upon the number of lines plotted. In this case, since we are plotting a single line, tuple consists of only one element. By using comma, we are unpacking the single element from the tuple and assigning it to a variable called Europe. And this allows us to directly access line 2D object and modify its properties, such as the label in this case. So comma unpacks the single element from the tuple and assign it to the variable Europe. Without the comma, Python will interpret the assignment as trying to assign a tuple to a single variable, would raise an error. So here it is needed at the first index, but here it is not needed because that is not a tuple, right? That is bar graph. So for bar graph, it is not needed, but for, I mean, only for you can remember as a simple part, only for line graph, line plot, it is there. For bar graph, it is not there. Scatter plot is not there. This is line plot, so it should be there. This is also line plot, it should be there, right? So for bar and scatter, it is not needed.
Okay.
See, this bar function that we have, plt dot bar, it returns a list, right? It returns a list. Remember this. Bar function returns a list. But that plot function, what does it do? Plot function, it returns a tuple. Plot function returns a tuple. So whatever function that we have, suppose it returns a tuple, you need to give a comma to assign that particular variable, right? I'll just show you one more example to this so that you'll understand this in more detailed fashion. Suppose I want to create a tuple with only single element tuple, right? Here also this is single element tuple, right? So if I write A is equals to tuple or Python, as I've created a round bracket, right? I wanted to create a tuple with single element, but if I check type of this, it is considered as string, right? Because it will not understand, right? Uh, this is string or a tuple. How it will understand? So by default, it will understand it as a string. But if you give comma here also, it will understand as a tuple. So if you are giving comma over here, it will understand this as a tuple to a single variable over here, right? For bar, it is not needed because that gives a list bar function, and this scatter also will give a list. Scatter also gives a list. It's a path collection object which represents a collection of scatter point. So this also does not give you the uh, tuple, right? So you can remember this example, this one and this one. Is it clear now, Harshini? Darshini, sorry. Is it clear, Darshini? Right? So that is what we have for the 5 graphs. You can add 6 graph. It is not needed for me. I mean, depending upon the type, you can add graph or bar graph or something like that. Now, this is for different rows, right? But what if you want single row, it in single row here. So how you'll do that? Let's see this. Only single row now this time. So here, no need to specify column. Only row is preferred. Only rows are preferred, right? So first is plot, correct? Second is bar graph, correct? Third I want is at scatter plot. So I'll just copy this and I'm going to paste it over here. And as I've discussed, I only want single row. So number of rows is not needed. It is redundant over there. Suppose I want number of columns equals to 4. So I only need to share y-axis, right? Obviously, if it is a single row, there's no need to share x-axis, right? Now, Europe plots this Set label as this. Europe. Here, no need to have this 000. No need to have this 1, but this is 1. This should be 2. No need to have this. No need to have this 2. What is that error? Name ERI is not defined, guys. This one. Now, I want to uh, have, I want to set color as red. So red color, right? I want to set color as USCA uh, or AX1. I want to set title. So I'll set title as this. AX1 dot set underscore title sales in USCA. This one. Here also, suppose title you want, you'll add X0 title, set underscore title, title as sales in Europe. So write down that. Sales in Europe. Here also, you want title as X2 dot set underscore title, setting title as sales in Africa. Done. But it is not looking proper, right? We should modify this. I'll just show you how you can change the size. Now, I need to define third graph, but that is little different. That is my bar graph for years and sales underscore Asia Pacific, comma, width for that graph should be 0.5 and color should be royal blue, this one. And Latin America, it should be also should be there at the third position. So there should be two bar graph between years and sales Asia Pacific, years and sales Latin America. Width is equals to 0.5, color is equals to sea green. Sea green. Right? If I run this, I'll get the error. I just need to write down years, not year. Right? It is done now. But we still have a problem with the size. Let us fix that. Setting a title is important over here. Title is sales in Asia Pacific and Latin America. AX3 dot legend, AX3 dot legend, Asia of 0, comma Latin America of 0, comma Asia Pacific, comma Latin America. Right? Done. Single argument position 3 should not be there. Latin America. Here we should close this. Right? Now we need to set size. Right? So figure dot set underscore size. Figure dot set underscore size underscore inches. So the figure size, I want it to be as large as possible. So 20.5 and 5.5. Can you see this now? It is changed and looking proper. And forward is equals to true. We'll just try to understand what is this forward is. Figure size is 20.5 is your width and height is 5.5. 20.5 is width and height is your 5.5 inches. Then next forward. It means this argument is used to specify how the figure should be resized. In this case, forward is equals to true means that figure will be resized proportionally, maintaining the aspect ratio. Right? So it is looking good now. And last thing you'll do is, it is not needed, but just remember plt.show. So in the same output, I am getting this particular point, right? One last thing is remaining for us, that is your box plot. We'll see it after the break. Sure. Write down this. I mean, just have a look at this. Okay, I'll just share one, what we can say, one file for this so that uh, you don't need to have a look at the notebook. I mean, you don't need to have this notebook as of now, even though I'm going to share it at the end of the day. But for your reference, you can refer this notebook. Copy. Yeah, this is your link. So you can try at home. You should practice this so that you will get a more command on this lines or this coding part. Right? Okay, we'll just go with the box plot and we'll take a break. So what is box plot? I want to plot a box plot, and it is also known as whisker chart. Sales across countries and product categories. A box and whisker plot or box plot is a convenient way of visually displaying the data distribution through their quartiles. The lines extending parallel from the boxes are known as the whiskers, which are used to indicate variability outside the upper and lower quartiles. And outliers are sometimes plotted as individual dots that are in line with whiskers. And box plots can be drawn. Either it can be drawn vertically or horizontally. So what I'll do is I'll just plot a box plot for you, and then I'll explain why it is needed, right? So this is your data, and I need to plot a box plot. So the function is plt.boxplot, and it should be in between sales technology, sales office supplies, sales furniture. Just a minute. So this is my box plot, right? And there's a cosmetic work that you can do for labeling your axis, adding a title. So I can take this and I can paste it over here to just add a label, to just add a title. Title is sales across countries and product categories. That is my title, right? And X label should be on the X axis. What do you have? Your product categories, right? X axis you have product category, and Y axis you can have your sales, right? And you should you want what is this one, what is this two, what is this three. So you want to represent 1, 2, 3. So what you'll do is you'll write down plt.xticks 1, 2, 3, comma technology, comma office supplies, comma furniture. So this is your data, right? And you don't want this. So what should do? What you should do? You should write plt.show so that you will not get that particular thing. It is done now. You can try this out, everyone. Write down this. All right. So I'll just explain what is box plot, and then uh, we'll have a break, right? So consider you are working as an employee in TCS organization. You along with 10,000 employees are there, right? You are interested to do wealth analysis, or rather salary analysis of your employees in your organization, right? So you have got data uh, of the 10,000 employees and their salaries. You are interested to do the analysis. So some employees might have high salaries. X-axis is salary, right? So x-axis I can stretch x-axis up to here, y-axis up to here. This is generally known as mean. So some employees have less salary, some employees have median salaries, some employees have low salary, right? Let's say x-axis is age. So you can have data over here. That's not a problem. But uh, all the employees will be having a certain range, right? Beyond which their salary will not exceed. So your analysis is going very good and sound. You don't have any problem with the analysis. Now you're trying to add, let's say you have 5 directors across India. You have 2 or 3 vice president or president, something like that. And there's one CEO of your organization, right? You have added this employees as well in your analysis. As their salary is humongously high, they will lie over here. CEO is over here, director is over here, VP and this kind of thing over here. Yes or no? So because of this, your analysis uh, is affected, right? Suppose if you are just considering this region, your mean salary is coming somewhere around 60,000 rupees. But if you, because of adding this employees, their salaries in 30 lakhs per annum, 50 lakhs per annum, or more than that, 1 crore, something like that. So your average annual salary of the analysis will become 2 lakh, right? But you have employees who have salary 20,000, 30,000, 40,000. So if I say the average salary of the employees being 3 lakh will become a problematic statement for me, right? It is not correct. It is incorrect. So because of inclusion of these points, this director, VPs and CEO, these are known as outliers, right? Because of inclusion of these points, they are known as outliers. It affects your analysis, right? So always you would be having in real world scenario, you would be having outliers. You need to treat that outliers. You need to remove that with certain strategies. In order to check if we have outliers or not, your box plot will help you out with that. Similarly, on the left-hand side, let's say if you're adding unpaid interns, right? Just your third year engineering students, unpaid interns. They are not interested in salary, right? They're interested to have experience. So they will be at the left-hand side, far extreme left-hand side. And because of this, unpaid students, let's say 10 students, your analysis will affect. It should be 60,000, 50,000, somewhere around that. Because of this, it is coming as 20,000. Average monthly salary of the employees is 20,000. Again, there is an effect, right? Because of the student. These are also known as outlier. So outliers can lie extreme left or extreme right within a spectrum, within a data, right? This is first point. So in order to get clear-cut information about the outliers, if outliers present in your data or not, you plot the box plot. It is a best tool to get the idea about the outlier. So horizontally, it look like this. I'll just show you what is this. This is known as Q1. This is Q3 quartile. This is upper whisker region. This is lower whisker region. And beyond this, if you have some data, beyond this vertical line, if you have data, that is considered an outlier. Simple. So just imagine you rotate this uh, box plot with the 90-degree. If you just write down vertical is equals to false. So you want horizontal box plot. So you'll be getting horizontal box plot like this, right? And as I've discussed, beyond this line, beyond this line and this line, this line, this line, this line. If you have data points that are known as outliers. So we have outliers over here, we have outliers over here, we have outliers over here. Yes or no? So box plot will give me a clear understanding of the box plot. Sure short understanding. Other tools also we have, plus minus 3 standard deviation and something like that. That is just gives me an idea about the outliers. But this is gives this me this gives me gives us the clear understanding of outliers if it is present or not in the data, because we're directly plotting, right? There is a statistics associated with this. So basically, what is Q3? I'll just explain what is quartile. What you do is, in order to simplify your analysis, you divide. Suppose your data is this, right? You divide your data into 4 equal parts. So as it is 100% data, dividing it into 4 equal parts becomes 25, 25, 25, and 25, right? So first 25 will be Q1, next 25 will be, first 25 will be Q1, next will be Q2, next will be Q3, and next will be Q4. So 25%, 25%, 25%, 25%. But first 25 will be Q1, next 25 will be Q2. This is also known as median because median is first 50% of the data, then this is 75% of the data, and this is 100% of the data. So that is your Q3. This is your Q3, and this is your Q1. So Q3 minus Q1 is your IQR. We'll discuss that. Whenever we are going to start machine learning and outliers part, we'll discuss that. Right? Is it clear now? Just a quick overview. Why there is need of outlier, box plot. What is the help of box plot? Is it clear, everyone?
Yes, people.
We are going to touch this topic afterwards as well. So don't worry about that. See, there's very vast syllabus and they only have given us 2.5 hours to complete that, right? It is merely impossible to cover everything. That's why we are, uh, that's why we need some extra sessions, right? See, let us see our syllabus. Now see, here, this particular session 10 is the entire, it is remaining. We have not touched that. That is a part of machine learning. I'm going to take this entire thing because it is very important. I don't want to finish this before machine learning. So there will be machine learning refresher, and I'll be clubbing that session in this because this is very important session. Rest of the sessions are completed. Box plot, pie chart, donut chart, a stack bar chart. We'll discuss that. Uh, Stack area, continuous chart. This is also remaining. But as a part of additional thing, I have taken modifications of the chart, right? Which was not there, but it is important because sometimes what happens is you need to have an understanding of how do we change the size of the figure. This is very important, relatively important. Next is you should know how do we have an understand how do we plot the multiple subplots. Third part, you should have an understanding of how to rotate the ticks, right? This is also very important. Sometimes most of the guys don't have an idea about this if the x-axis is overlapping. So it's very simple, right? That is why we have taken that. Additionally, I am planning to take one more case study. By taking out that case study, we will be uh, completing this particular session. So the case study name is Play Store, Google Play Store data cleaning and analyzing your The exploratory data analysis is Python, finding useful insights. So it will summarize your everything, like it will cover all the aspects from handling missing data, this one, then plotting charts, this different charts, right? Then pandas data frame, group by, and data handling, and this kind of thing, list and tuple. So you can consider this as a mini project summarizing your module number 1, 2, 3, 4, 6, and 7, right? So we'll do that now. I'll just give an understanding of that particular data, and we'll stop here for the day. So let me take out that. Yes. So I'll just renaming this as Google Play Store case study. This is the additional part, right? It is not there in syllabus, but it's very important. I wanted to take this. So here we'll take this data and we'll create new notebook, right? So I'll just load data and I'll explain you what this case study is all about. We can discuss this in tomorrow's session. So let me copy the problem statement. Yeah. Okay. So this is your problem statement. In this module, you will be learning data visualization with the help of case study. This will enable your understanding of how visualization aids you in solving business problems. The problem statement over here is the team at Google Play Store wants to develop a feature that would enable them to boost visibility for the most promising apps. Now, this analysis would require a preliminary understanding of the features that define a well-performing app. You can ask questions like, does higher size or price necessarily mean that app would perform better than other apps? Second is, or does a higher number of installs give a clear picture of which app would have a better rating than other, right? So session 1 will be introduction to data visualization. Here we'll importing necessary libraries and data. We'll import pandas as PD, import numpy as np. Then I need to read the data and check the first 5 rows. So I'll write down input 0 is equals to pd.read underscore csv. The file name is Google Play Store, this one, and we'll just check input 0.head. So that is your data is all about. If you see, the data is very uncleaned. For an example, uh, this type or the columns are mismatched. If you just see over here, the columns are mismatched. For an example, or if you just check the shape of the data frame input 0 dot shape. We have 10,841 records and 13 columns, and we'll just have a look at data handling and cleaning part, right? So we need to check the missing values. We'll write on input 0 dot is null dot sum. We have 147,074 missing values in rating columns and multiple missing values, so we need to treat them. This thing we'll do it after in tomorrow's session. And this case study, as I discussed earlier, will take care of your uh, syllabus, which it will take care of your handling missing data, outlier detection, and how to clean them, textual data cleaning, meaningful data transformation if it is required. We'll see that. So by completing this case study, we are going to complete this module, this session as well, right? So that is what we have. I'll not share this notebook with you because we have not completed anything, but I'll share this notebook on your drive. Now, if you have any questions, you can ask. Otherwise, we'll stop here for the day. Yes, guys. Do you have any questions? Any suggestion? Any question?
Well, we got a mail to submit some case studies, like when we need to do that.
I'm not aware about that. What is that, man?
But,
Can you show your screen?
yes, yes, on screen, sure. But can you able to see my screen?
Yeah, yeah. Yeah, what is this?
They have mentioned no deadline, but they have sent a assessment login.
Uh-huh. See, Python MCQ you can solve, Python program you can solve, pandas you can solve, SQL you can solve. Visualization is still remaining, but EDA you can solve. So
Oh,
first six you can give it a try. First six.
okay, okay, okay.
Is it possible to save these charts? Yeah, you can save that in the form of PNG format or JPG. You can save that. What is the difference between case and function? I am not understanding this question. Like case and function. This is related to SQL or Python? SQL. Okay. Uh, Function is it's we have discussed this no in the last session itself. syntax. So if you have, yeah. See, what is, I mean, their end purpose, end goal is same only. Suppose you have to bracket your data into income tax slab, right? So this is your known as case statement. You use case statement, and if you're passing that statement, if income is less than 10,000, tax rate is 0.1. Else if income is less than 25,000, less than or equals to 25,000, tax rate is 0.2. Else is this. So that is your case statement. But you are creating a function, you have to call that, as you have seen in your Python as well. You are creating function with df, this calculate tax rate income. If income is less than or equals to 10,000, same code will be there, and you are just storing that in tax rate is equals to, how do you call this function? You call it by using a this, right? So that is your function. They serve the same purpose, but their syntax is different, right? In your code as well, if you just see, we have discussed user defined function and case statement, but their end goal is same, right? Only difference is with the syntax. So this is your statement, this is your syntax for case, and this is your syntax for functions, right? So use a case statement for straightforward conditions and assignment. If you have complex conditions, complex calculation, you use a function uh, to encapsulate complex calculation and improve code readability. Reusability, functions are ideal for reusable code blocks. For large data sets, case statements can often be more performant than functions. You can read this thing. But there is no difference as such. Only difference is in syntax. How to get XI files? Which files?
Vibal, morning you taking the Excel file data, right?
No, 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 no. It is not Excel. We are just creating your array. Can you see that? These are arrays. These are only arrays. So I've shared this notebook on your drive, no? The array. Excel we have not loaded. We have not loaded the Excel file.
Okay.
All right, then it's already a time. We can stop here for the day. Tomorrow we'll continue with the same case study, and if time permits, we'll start with the machine learning module. Right? Cholo. All right, everyone. Thank you. Happy learning. Bye.
Thank you.
Thank you, Vipul.
Thank you, Vipul.
Yes, bye. Thank you.